Cross product is a tool of algebra, to be precise, it's a tool of ratios which we use to solve certain equations quickly with the help of the patterns which we have observed over time. It has its proof algebraically, which we'll show right now, and after that we'll show what patterns we have observed and how we use it, and then we'll solve an example. First of all, we'll arrange this equation so that we can eliminate one of the variables. The equation here is a naught x plus b naught y plus c naught is equals to 0, and a1 x plus b1 y plus c1 is equals to 0, and we want to find the values of x and y. So we want one variable in the equation so that we can easily find the value of it, arranging it in the form of the other values which we have, that is a naught, b naught, c naught, a1, b1, c1. For that, we'll have to eliminate one of the variables from both the equations. For doing that, we'll write it like this: a naught x is equals to negative b naught y plus c naught, and a1 x is equals to negative b1 y plus c1. Now we can see that we have two equations, let's say 1, 2. We'll divide the first equation by second or divide second by the first, it doesn't matter, we just want to eliminate x from both the equations. We'll divide first from second in our case, and we'll find a naught over a1 is equals to, since negative upon negative is positive, this will be b naught y plus c naught over b1 y plus c1. And now we want to eliminate the denominator, so we'll multiply both the equation by a1 and b1 plus y, b1 y plus c1, that is b1 y plus c1 and is equals to b naught y plus c naught into whole into a1, and that will be a1 a naught b1 y plus c1 a naught, that is equals to b naught y a1 plus c naught a1 c naught. I'm sorry for that. Now we'll arrange this equation in a form so that we can find the, we can factor out the y from the equation and keep it on the other side and keep all the other values together. For doing that, we'll subtract both the equation from b naught y into a1 and c1 a naught. So here we'll get a naught b1 y minus b naught a1 y and c naught a1 minus c1 a naught, and we can factor out the y, and we have here a naught b1 minus b naught a1, that is equals to c naught a1 minus c1 a naught. And now y will divide both the equations from a naught b1 minus b naught a1, so we will end up with c naught a1 minus c1 a naught upon a naught b1 minus b naught a1. So we have found the value of y. We'll do similar thing for x2. Let me do it and then I'll talk about it. We observe here that x and y both have same denominator, so we can shift that denominator to the other side by multiplying both the equation with the denominator in both the cases, and we find the value of c1 b naught minus c naught b1 upon x to be equal upon x to be equal to, let me write it, upon x to be equal to c naught a1 minus c1 a naught upon y, and which is equal to a naught b1 minus b naught a1, and we want the x to be on top. So now we'll find the reciprocal of all the equations which we have observed here, which are equal. So 1 upon a naught b1 minus b naught a1 is equals to x upon c1 b naught minus c naught b1 is equals to y over c naught a1 minus c1 a naught. Now this is the equation we have obtained here. The pattern which we observe are this. Suppose we arrange the coefficients of y in this order from both the equation and b1, and then the coefficient, or to say the term c of both the equations, and then the coefficient of x from both the equation. We have to arrange in a certain order. The coefficient of the first equation or of the same equation will stay in the same horizontal line. Goes for it's same for both the cases. The second equation will be in the second horizontal line, and we'll arrange it, and we'll again use the coefficient of y here. And what we observe is, suppose if we say that b naught into c1 is multiplied with c1, and if we are going down, let's say it's positive, and we have the first value to be positive, so we say that if we are going down, it's going to be positive, and when we go up, it's going to be negative. b1 c naught, b1 c naught. It's just a pattern which we have observed, and we are using it. It does not have, I mean, it has a proof. This is the equation we have solved, but it's some sort of trick we use to quickly do the equation, something we have memorized in our mind. Again, c naught a1 and c1 a naught. Again, we observe here c naught a1 is positive and c1 a naught is negative, and a naught b1 is positive and a1 b naught is positive. I mean, I've said the opposite. a1 b naught is negative. This is what we observe, and we keep on using it. This is the example which we are going to solve, and we're going to eliminate x, y, z from these equations. The equations are ax plus hy plus gz is equals to 0, and hx plus by plus fz is equals to 0, and gx plus fy plus cz is equals to 0. I'm not going to do the rigor which we did initially while we were proving the equation, the cross product. We are simply going to solve it with the patterns which we have observed, arranging the coefficients of y, x and z's. Here for the first equation, we know that h, and then c, and then a, and then again h. And of the second equation, we have b, and then we have f, and then we have h, and then we have b again. X upon hf minus bg is equals to y over gh minus af is equals to z over ab minus h square. This is what we end up with. And suppose they are equal to some constant, constant k. Okay. So we can write x is equals to k into hf minus bg, and y is equals to k into gh minus af, and z is equals to ab minus h square into k. And we are going to use this value of x, y, z into the third equation, that is gx plus fy plus cz. So since we have the constant k in all three terms, we are going to just simply remove it, because we'll factor out k from this whole equation, and since the whole value is equal to 0, 0 upon k is going to be 0. So I'll directly write g into bf minus gh plus f into gh minus af plus what's the third value of z? That is ab minus h square. Okay, what was c into ab minus h square is equals to 0. Now we have bgf minus g square h plus fgh minus af square plus abc minus h square c is equals to 0. We have, see, this was the mistake we have done. X was bg, not gh. So here I have wrote it in a very bad way. That's my bad. And then it's going to be g square b, and then we have fgb fgb2 fgb plus abc minus g square b minus af square minus b square c is equals to 0. Here this is h. This is h. This is h. Okay. It's going to be h. It represents an h. Okay. So this is how we have eliminated x, y, z from all three equations, from this equation, with the help of cross product, which was the basic idea which we have just mentioned. To say how we have used z here, for that we'll prove it too. Suppose that there was this equation a1x plus b1y plus cz is equals to 0, c1z, and a2x plus b2y plus c2z is equals to 0. We'll divide both the equation from z, and we'll write it here like this: 0 and a2x over z plus b2y plus c2 is equals to 0 over z. Sorry. And now we can consider x upon z to be a variable itself and y upon z to be a variable itself. And then we'll multiply all the three equations with z. So then we'll end up with b1 c2 minus b2 c1 equals to y over c1 a2 minus c2 a1 upon c a1 b2 minus a2 b1. And then this is how we did the first case. We observe that this ends up like this.